All right, guys, we're going to go ahead and work on our notes. In the regular statistics, this may be on a different day. I'm not exactly sure what that one is. But regardless, in both classes, the topic is generalizing to the population of interest. So the key here is that you have to have a clear indication or a clear understanding of what's the population you're talking about. Is the population just Miss McClellan's students? Is the population all of Aledo ISD? Is the population that you're wanting to make a generalization about um, just Aledo High School? Or is it Texas? Or is it, what is the population? What group are we generalizing to? All right. So the population of interest is this population that the sample results are intended to be representative of and to be generalized. It's important that we have that clear idea of the population we want to generalize to so that we can decide if the way we are sampling is giving us a sample that is representative of who we want to generalize to. If I want to generalize to all of Texas, but I just ask people in Aledo, then that's not going to be an adequate or a good representative sample because I know that people in Aledo are not representative of all Texans. Okay? That idea. So here we go. So we're just going to jump straight into some examples and see what you can follow along with. So here we go. Example 1. Researchers want to know the opinions of adults in a large city to see if they think drinking is a bad problem in that city. Researchers waited outside a bar they randomly selected from a list of such establishments in the city and asked every 10th person coming out of the bar. All right, so identify the population of interest. Reread, see if you can't figure out who are they trying to state that this is an opinion for? Okay, who are they wanting to conclude about? So I see in that first sentence, researchers want to know the opinions of adults in a large city. So whatever large city that is. So that's a quick little blip in the sentence that says, hey, they want to generalize to all adults in the city. So that's what we're going to say is the population that they want to generalize to. So I'm just going to say the adults in I have a typo there, large city, this large city. Maybe I could say whichever large city they're talking about here. Okay. All right. Identify the sampling method. Now, I see that, man, this every 10th thing, every 10th person coming up. Okay, so we know that that's something. That's one of our sampling methods. So let's think back. Hopefully they're going to start at a random place and then they're picking every 10th one after that. That's a system, a systematic way of sampling. So they're they're indicating systematic sampling, okay? But I do actually want to talk about something else in regards to that, okay? Systematic. Now, here's the other thing. Let's think about this. They want to get the opinion of all the adults in this large city, okay? All adults. But let's think, who are they sampling? Okay? So it says they let's see, they want to see if they think adults think drinking is a bad problem. Okay. The researchers waited outside a bar that they randomly selected. So, they're making it sound all good and everything because they randomly selected this bar. However, okay, let's see here. It's people outside of a bar, and they're going to ask them about their opinions on drinking. Hopefully you can get that in your mind. There's some kind of problem there. Okay? So I can tell right now in my mind, this is not going to represent all adults. Okay? It's about drinking. They're asking people coming out of a bar. So those are going to have a certain kind of opinion. Probably people coming out of a bar are like, Not a big deal. Drinking's good. We're good. I'm good. We're good. Okay. So for this systematic sampling, I mean, you might consider also, and I don't think I would take off for this, but technically, this is also a type of convenience sampling. So that's also kind of going along with this. Systematic, definitely, because they're talking every 10th, but keep in mind, because this plays into the next thing, identifying bias, that this was definitely convenience. Okay, so here we go. Identify the type of bias, if any. All right, so we just talked about this. We want to know opinions of adults about drinking, and we're asking people coming out of a bar. So, what's that called if we're just going to get people who are coming out of a bar? And that's definitely not like everybody, all adults in that city. What do you call that when you're leaving out a portion of the population? Undercoverage. You're systematically leaving out a portion of the population. They're not getting counted for. Okay. Now, if there is bias, to what population do you think researchers have the right to generalize to? Okay, so that's a good question. So if they just asked people coming out of bars, now it was a randomly selected bar. So do you think we can just generalize to patrons of this bar? Or do you think we could go ahead and do patrons of all the bars in the city? I don't know the city, so I don't know if it's way different. Have bars in one part of town is way different than the bars in another part of town. That's very possible. Like a 7th Street bar may be way different than ones that are just like way over on in North Side bars. I don't know. So I'm not quite sure. I know I would be safe generalizing to the adults that go to this bar. So let's play it safe. Okay. So I think I could generalize to all adults who go to this particular bar. Okay. We might have said all ones in the city, but it's a large city, so I'm not really quite sure if that's true. Okay. If there is bias, create a new sampling method which will provide a sample that is more representative of the population of interest. So how could I sample all adults? Give me a way to let's think about this. I hadn't even thought about it. Let's see. I mean, there's many, 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 many answers. So let's see here. Here's one that I had come up with. Select every 10th person at a randomly selected restaurant. Oh, at not a randomly selected restaurant. Maybe I'll do at 15 randomly selected restaurants across the city. Okay, randomly selected restaurants across the city. That's one way. What about, the randomly selected, maybe you could do the grocery stores, whatever. I picked more than one restaurant because I was afraid in a large city, one restaurant might not be the same kind of patrons as all of them. And so I thought maybe by picking 15, hopefully I'll get a good sampling of those kinds of restaurants. Okay. All right. Lots of different answers there. Very good. Let's go on to the next one. Example 2. The Environmental Protection Agency wants to identify the quality of soil and groundwater within 100 square miles away from a former industrial waste dump for the evidence of toxic chemicals. Here in Aledo, I would suspect and I bet that they do testing of the groundwater and all the soils and everything around because they're off a link crest. There's a big dump There, that's where a big waste management plant is. Okay, so I would imagine that we've got testing going around here to make sure everything's going okay. All right. In order to do this, researchers used a map and they sectioned it off in 1/10 square mile increments. The sections are numbered, and then a random number generator is used to select the sample. Okay, simple random sample. Random number generator, all of the increments are put in there, they're labeled, all of them in there, and then simple random sample. And so every possible sample of every size is equally likely. So this is interesting what happens here. Just by pure randomness, it just so happened that all of the samples that were randomly selected were between 95 and 100 miles from the former industrial waste dump. Okay, so why might that pose a problem? Or would it? Is that acceptable just to test the soil and water in miles 95 to 100? Okay, let's think about that. All right. Identify the population of interest. So go back and read, who are they wanting to make a claim about? What's the entire population they want to make a claim about? Right here, I see it. The EPA wants to identify the quality of soil and groundwater within 100 square miles of the former industrial. So they're wanting to make a statement about all of the within 100 miles. Okay. So in fact, I'm going to just type exactly what it says. So the population is the soil and groundwater within 100 square miles away from a former industrial waste dump. All right. Identify the sampling method. Okay. So they sectioned it all off into 1/8 or 1/10 square mile increments, used a random number generator. So they did all of those things. They just did a random number generator. So that's a simple random sample because all of the mile increments, square mile increments, 1/10 square mile increments had an equal chance of being chosen. So that's a simple random sample. All right. And just by pure randomness, they all happen to be the ones from the 95 to 100 mile range. So identify the type of bias, if any. Okay, so let's see here. What do you think? What would we call that? I just got 95 to 100 miles out. And I don't think that's like all the other first 95. What do we call that when part of the population, and in this case, a big part of the population, is not represented? What do you call that? It's actually the same as what we had up above. That is also under coverage. Okay, because miles, 0 to 95 are not represented. All right. I didn't indicate that up here. I didn't state that, but just FYI, that's a good point to make. This one up here was under coverage because um, only adults coming out of a bar are represented. Okay, so not like all of them. Okay, sorry, back down to here. Okay, if there is bias, to what population do you think the researchers have the right to generalize? So who could they generalize? Hopefully you can tell. They can generalize to the miles 95 to 100 away from the waste dump. Okay. If there is bias, which we said there is, create a new sampling method which will provide a sample that is more representative of the population of interest. So we want to make sure we get all of them. All right. So I'm going to let you think about that. You might pause right now and kind of think about that. I'll talk to you about what I put down, and I'll write mine out. So here we go. Okay. I'm not sure that I wrote it, incredibly wonderfully, but the key was I wanted to make sure that all the distances were represented. So I'm going to choose to stratify by that distance from that waste dump. So I decided to stratify into the 5-mile increments. So I'm going to select 10 soil and water samples. I like this, like using original method. Because I like how they described the 1/10 of increments and did a random number generator. Okay. From 0 to 5 miles, 5 to 10, 15 to 20, and so on and so forth. Okay. All right. So that would be a good representation. And there's lots of different ways you could say that, but there's just one. So I make sure I get all types of land. Okay. So I hope this clarifies what you're going to be doing here on this next page. Same idea, just carefully reading who you think they intended it to be generalized to, and based on the method, who do they have the right to generalize to? Is there a type of bias? What's happening? We have to get those things straight so we know if we got a good sample that is representative of the population that we want to generalize to. Okay? All right. Hope that helps you. And there you go for generalization to the population.